Am I audible?
Yeah, ma'am.
Okay. So is my screen visible?
Yes, ma'am.
So let's start today's session. Good afternoon, everyone. I'm your TA Vidushi, and today is our problem solving session 3. So in this session, I will discuss about some questions related to vibrational spectroscopy, Raman spectroscopy, and rotational spectroscopy. So, what do you understand by vibrational spectroscopy? The vibrational energy of a molecule corresponds to the infrared frequency. The interaction of infrared radiation with molecular vibration gives infrared spectrum. A molecule in the ground state can possess three energy levels. It can be electronic energy level, it can be vibrational and rotational energy levels. The absorption in the IR region is due to the changes in the vibrational as well as the rotational energy levels. So, when an electron absorbs the IR radiation, then the IR radiation is absorbed due to the changes in the vibrational and rotational levels. As you know, like there are electronic levels and then there will be vibrational levels, and in vibrational levels there will be rotational levels. When an electron absorbs less energy, rotational transitions takes place. The spectrum observed is rotational spectrum, and when the electron absorbs higher energy, then the vibration transition takes place along with the rotational transition. And here the spectrum observed will be vibrational rotational spectrum. And the rotational spectrum is observed in the far IR region, while the vibrational rotational spectrum is observed in the near IR region. As in IR, it is divided into three: near IR, middle IR, and the far IR region. The wavelength ranges in the of the near IR will be zero point 0.8 micro to 2.5 micro, while in the middle IR it's 2.5 to 15, and in the far IR it ranges from 15 to 200. While if we look upon the wave number, then it will be 12,500 to 4,000 centimeter inverse for the near IR. For the middle IR, it will be 4,000 to 650 centimeter inverse, and for the far IR, it will be 650 to 50 centimeter inverse. Also in IR, there are two type of region. One is the fingerprint region, and other is a functional group region. Functional group region. So basically, there are two types of regions in IR: fingerprint and the functional group. Now we will look upon the mode of vibration in this spectroscopy. So in IR, there are two types of mode of vibration. The one is the stretching and second one is the bending. In stretching, there are further two types. It can be symmetrical and it can be anti-symmetrical. In stretching, the bond length changes, while in bending, the bond angle changes. In stretching, in symmetrical, the atom of a molecule move in the same direction. Either it will be towards or away, but it will be in the same direction. Then it is called as symmetrical stretching. While in anti-symmetric stretching, it will be in the different direction. Like here, if you see, it is moving in this direction, and from here it is moving from the away. So it is anti-symmetrical. Now moving to the second mode of vibration, that is bending. And further in bending, There are further four types: scissoring, rocking, twisting, and wagging. Out of these, scissoring and rocking are the in plane bending modes. In plane, while the twisting and wagging are the out of plane bending modes. So basically, in the in plane bending, the first one is scissoring. In this, the bond angle will decrease, while in rocking, the bond angle will be maintained but will be in the same plane. So that's why these two are called as in plane bending. While the other two can be out of plane bending modes that consist of twisting and wagging. In twisting, one atom will be in above of the plane while other will be in below the plane. That's why it is out of the plane bending. While in wagging, both the atoms will be in the same plane. So basically there are two type of mode of vibration: stretching and bending. In stretching, it will be further of two types: symmetrical and anti-symmetrical. While in bending, it will be of four types, that is scissoring, rocking, twisting, and wagging. So how do we calculate the number of modes in IR spectroscopy? Suppose if your molecule is linear molecule, let us take an example of CO2, as CO2 is a linear molecule. So in linear molecule, we can calculate the number of modes by the formula 3n minus 5, where n is the number of atoms. So here there are 1, 2, and 3. So it will be 3 into 3 minus 5. That is 9 minus 5. That is 4. So in CO2, it will have 4 normal modes. But if we just take an example of non-linear, non-linear can be like water. As in water, it has a bent shape. So in water, the number of moles can be calculated by the formula 3n minus 6. So it can be 3. Here also the n will be 3, as there are 3 atoms, minus 6. So it will be 9 minus 6, that is 3. So in water there will be 3 moles. So just you have to remember, for linear it will be 3n minus 5, and for non-linear it will be 3n minus 6. Now just look here, it is symmetric type of vibration. Here there will be no change in dipole. So IR will be here, it will be inactive. So for IR to be active, there should be a change in dipole. Like IR active modes require dipole changes during rotations and vibrations. Now if you just look in asymmetric, then it move in different directions. So there will be changes in dipole and it will be IR active. Like in scissoring, there will be change in dipole and it will also be an IR active. So for IR active, there should be change in dipole moment. That is, dipole moment should not be equal to 0. Now we will look upon some of the questions related to this. So can anyone tell me what do you understand by the Hooke's law?
F is equals to minus kx.
Okay. According to Hooke's law, displacement x and the restoring force is related by F equals to kx, F equal to kx square, F equals to minus kx, or F equals to minus k2x. So it will be F equals to minus kx. Why it is minus? Because it is a restoring force.
Restoring force is in the opposite direction.
Yeah, that's why It is F equals to minus kx. Now moving to the next question. A bond vibrational frequency depends on bond energy, force constant of the bond, masses of the atom involved in bonding, both B and C. Like bond vibrational frequency, mu. Will it depend upon the bond energy or the force constant or the mass of the atoms that are involved in bonding? So can anyone tell me the answer? You know this formula mu is equals to 1 upon 2 pi under root k by mu, where your mu is the frequency, k is the force constant, and mu will be the reduced mass. And for reduced mass, it can be written as m1, m2, that is mass of the both atoms, and then divided by sum of the masses of atoms, m1 plus m2. So now they're asking a bond vibration frequency depends on bond energy, force constant, masses, and both B and C. So it will be both B and C. Like here, you can see frequency depends on the force constant as well as the masses. Now you have to calculate the theoretical number of vibrational degree of freedom in benzene. So how you will calculate? I've already discussed
3n minus 6.
3 and minus 6. As you know, benzene
Linear molecule.
is a non-linear molecule. It's not a linear molecule. Benzene is C6H6. So it will be a non-linear molecule. So for non-linear molecule, we use 3 and minus 6. So 3 and will be 12, like 6 carbon, 6 hydrogens, and will be 12 minus 6. So it will be 36 minus 6, that is 30. So the vibrational degree of freedom in benzene will be 30. So what about CO2? We already discussed
3n minus 5.
3 and minus. CO2 is a linear or non-linear molecule?
Linear molecule.
CO2 will be a linear molecule. So here it will be 3n minus 5, like n is 3 here, like 3, there are 3 atoms. So it will be 9 minus 5, that is 4. Now what about water?
Non-linear molecule. 3n minus 6.
Why water is non-linear molecule? What is the shape of water?
Angular shape.
Yeah, it will be bent or V shape. Like for water, it will be like this. It's H2O. Here also N will be 3. So it will be 9 minus 6, that is 3. So now what about sulfur dioxide? What will be the vibrational degree of freedom in sulfur dioxide? Just tell whether it's linear or non-linear. If it will be linear, then it will be 3n minus 5. If in case it is non-linear, then it will be 3n minus 6.
Non-linear.
Pardon? It's non-linear, yeah. Sulfur dioxide. It will also have the same shape like water. So it will also be non-linear. That means 3n minus 6. Same here also in sulfur dioxide there will be 3 atoms. So 3 into 3 minus 6, 9 minus 6, that is 3. Now what about the methane?
Non-linear.
Methane, like what is the shape of methane? It's
Tetrahedral.
it's that. So here also we will apply 3n minus 6, and in methane n will be 5 because there are 4 hydrogen, 1 carbon. So it will be 15 minus 6, that is 9. So is it clear how to calculate the vibrational degree of freedom?
Yes, ma'am.
Okay. Now the next question, the following characteristics absorption peaks have been observed in the infrared spectrum of an organic compound having formula C2H6O, where a strong band will be there at 3300, another band at 2965 centimeter inverse, another band at 2920, and another band at 1050. So what will be the compound? You know from IR spectrum, it is used for like functional group detection. Now, if you look at 3300, which functional group will appear at this? 3300. And it's a strong band. In IR, the band can be of strong intensity, weak, or medium intensity. So it's a strong band at 3300 centimeter. So what does it corresponds to? So for 3300, it will be a OH. So in IR for OH, always there will be a strong band at 3300. Now there is another band at 2065 and 2920. So these two bands corresponds for the CH stretching. CH stretching. There is another band at 1050. So can anyone tell me like at 1050 which function group can present? Like whose characteristic peak is there at 1050? So at 1050 it will be for the primary alcohols. So always remember, if there are primary alcohol, then in IR it will appear at 1050. If there is OH, then it will appear at 3300, and the for CS stretching, it will be near about 2900. Now you know that the formula is C2H6O, and it has one OH, and that OH is a primary alcohol, and you have CH also. So what will be the compound?
Ethanol.
Ethanol.
Okay. Now moving to the next question, how will you differentiate the following pair using IR spectra? The first one is aniline and N-methyl aniline. Now you know the structure of aniline. It will be C6H5NH2, that is this, and NH2. And for N-methyl aniline, it's one hydrogen of aniline is replaced by methyl, so it will be N-methyl. So how you will differentiate based on the IR? Like you have to differentiate aniline and N-methyl alanine. So you can differentiate it by NH stretching. You know, here primary, as it is attached to only one carbon. Here it is secondary. Primary and secondary. So whose stretching will be more? The NH stretching of, like this, suppose this is A and this is B. What will be the NH stretching of these two? First one is primary and second is secondary. So for aniline, what will be the stretching frequency for the NH stretch? So for aniline, it will be approx 3400, and for and methyl aniline, it will be approx 3450. Now moving to the next, acetaldehyde from ethanol. So how you will differentiate acetaldehyde? Acetaldehyde is CH3 CHO. from ethanol. Ethanol is C2H5OH. So here you can clearly differentiate. So how you will differentiate these two, acetaldehyde and ethanol? Like see here also CH stretch will be there, here also CH stretch will be there. So what will be the differentiating factor?
Oh, it's stretching at 1300,
OH stretching at
3300.
okay. And what about acetaldehyde? Like you see in acetaldehyde there is CO, C double no stretching. So what's the characteristic absorption peak of C double O? Where it is observed? Like it's correct. Like for OH it will be 3300. But what about this? The carbonyl of acetaldehyde. So the carbonyl will be at 1730, while the OH stretching in ethanol will be approx at 3630 centimeter inverse. So these values you should remember, like what are the characteristic peaks of like CA stretching, C double bond C stretching, for the amines, for the alcohols. These all values you have to remember. Like here for aniline, it's approx 3400. For N-methyl aniline, it's 3450 centimeter inverse. For acetaldehydes, the carbonyl stretching will be at 1730, and for ethanol, as it is OH stretching, it will be at 3630 centimeter inverse. Now the next question is, what will be the force constant for the bond if in HCl if the vibrational frequency is 8.667 into 10 raised to the 13 seconds inverse? It will be like this, 10 raised to the 13. So what will be the formula by which we can calculate the force constant? We have already discussed. The vibrational frequency is given. You just have to calculate the force constant. So what's the formula to calculate it?
U is equals to 1 by 2 pi root over k by nu.
Okay, it's mu equals to 1 by 2 pi under root k by mu. So the value of vibrational frequency it's given. For k you have to calculate. And what about mu? How you will calculate mu?
M1 M2 by M1 plus M2.
Yeah, and mu is the reduced mass. So first we will calculate the value of mu. It will be m1 m2 divided by m1 plus m2. So now we are here talking about HCl. So the mass of hydrogen and mass of chlorine atom. We have to calculate. So for mu, like what's the mass of hydrogen? It will be approx 1.0078, or you can write directly as 8 multiply by mass of chlorine, that will be approx 35.5, and 1.008 plus 35.5. Also, we can convert the mass by multiplying it by 1.66 into 10 minus 24 gram, and for gram to kg it will be like 27. Like I will just wait. Like here, like for hydrogen, it's 1.0078 to be precise, but you can write as 1.008. So we will multiply it by 1.66 into 10 minus 24 grams. So just to convert in kg, we will write directly as 10 minus 27. So it will be in kg. So the exact mass of hydrogen by solving it will be 1.67 into 10 minus 27 kg. Similarly, we have to calculate the mass of chlorine. It will be 35.5 into 1.66 into 10 minus 27. So here mass will be approx 5.89 into 10 minus 26. So from here, mu is equals to m1 m2 divided by m1 plus m2. So you will just multiply these two values. That's 1.67 into. Has anyone calculated what will the value of reduced mass?
1.8 into 10 power minus 27.
1 point?
9.8 into 10 power minus 27.
No, it's wrong. Just check your calculation once. To 10 and just add it 1.67 into 10 minus 27 plus 5.89 into 10 raised to power 26. So the value of reduced mass after solving will be equal to 1.6 into 10 raised to power minus 27. Oh, sorry. Uh, just a second. Yeah, now I'm right. Here, I think after solving, it will be, sorry, 10.24. Hmm. Right, 10 minus 27 kg. No, it's 27. And just check. I think it will be 27 only. So now you got the reduced mass. So if you will put the value here, it will be 8.667 into 10 raised to the 13 equals to 1 by 2 into 3 into 1 4 3.14 under root of k that you have to calculate, and mu you already calculated out, that's 1.6 into 10 minus 27. So what will the value of k? So what will the value of k?
5.7 into 10 raised to minus 3.
It will be approx 483.1. Now move to the next question. Calculate the approximate wavelength of absorption associated with CH bond in stretching vibration of methyl group. The force constant is given by 5 into 10 raised to 5. Mass of carbon and hydrogen are given 2 into 10 raised to 23 at 0.167 into 10 minus 23 gram respectively. So you just have to calculate the wavelength. So how you calculate the wavelength? K is given, masses are given. So firstly you calculate the frequency. First let me erase this. So recite the formula. You know this. So now for this wavelength, you need to know the value of this. So you know this formula. It will be 1 by 2 pi c under root k by mu. So just substitute the values. 1 by 2 into 3.14. C will be the speed of light, that will be equal to 3 into 10 raised to 10 in centimeter per second. And K, it's given 5 into 10 raised to 5. And masses are also given. So mu is m1 m2 upon m1 plus m2. So just it will be 2 into 10 raised to 23 multiply by 0.167 into 10 minus 23 and divide by sum of these two masses. So has anyone solved it? What will the value for the for this? Has anyone calculated it? What will the value? Just now you have to just calculate everything. Like you substituted each value in this equation. Just solve it. It's 1 divided by 2 into 3.14 into 3 into 10 raised to 10, then under root 5 into 10 raised to 5 divided by mu. So what will be the value? So after solving it will be 3023 centimeter inverse. Now it's we have to calculate the wavelength and it is reciprocal of it. So just it will be 1 divided by 3023. So what will be the answer for the wavelength? So what will the value of wavelength? It will be 3.31 into 10 minus 4 centimeter. Or you can simply write it as 3.31 micrometer. Na, it's like centimeter. So micrometer is 10 minus 6. So it will be 3.31 micrometer. Is it clear up to here? Is it clear?
Yes, ma'am.
Okay. Now the next question. Calculate the vibrational absorption frequency of the carbonyl group if force constant of the double bond is 1 into 10 raised to a 6. So I'm giving you 2 minutes time to solve it. Just you have to calculate the frequency. Force constant is given. Just tell me the value of mu. K is given. Mu you have to calculate. Like you have to calculate by multiplying the mass and divided by addition of the masses. Just solve firstly the value of mu. Then substitute the value of mu in this and then calculate the frequency. It's carbon CO. So the value of mu after solving will be approx 1.14 into 10 raised to power minus 23 gram. So like here, if you will substitute the value 1 by 2 into 3.14 under root of k. K is 1 into 10 raised to power 6.
And answer is 1687.32.
1 6. What was the answer?
1687.32 centimeter.
It will be 1574 centimeter inverse. Like this. So this will be the value of the after solving this. So the value comes out to be 1574 centimeter inverse. Now moving to rotational spectroscopy. The transitions among rotational energy levels of the ground vibrational state which corresponds to the ground electronic state are studied under pure rotational or microwave spectroscopy. So how you will know whether a molecule is microwave or rotational active? The molecule which have a permanent dipole moment only they will be rotational or microwave active. Like let's consider heteronuclear diatomic molecules. Diatom means they're two atoms like HCl it consists of two atoms so they are diatomic. Heteronuclear means different nuclear like this is hydrogen this is Cl so they're heteronuclear. So these all are microwave active as there is a dipole moment like in HCl, CO and no HBr. While in homonuclear, homo means same like in H2. In this case, there will be no permanent dipole, so they are not microwave active, or you can say they are not rotational active. Like for triatomic molecules, it's H2O. Here also there will be permanent dipole moment, so they all are microwave active, like H2O, N2O, OCS, ammonia, and chloroform. So just remember, those molecules will have which have a permanent dipole moment, that is, whose dipole moment will not be equal to zero, then only they will be rotational or microwave active. And this condition is known as the gross selection rule for the microwave or the pure rotational spectroscopy. For a pure rotational spectrum, delta J should be plus minus 1. Now let's solve some questions related to this. Among the following molecules, which one shows pure rotational spectra? N2, H2S, CO2, methane. Now you know the condition that why a molecule will be rotational active or microwave active. So what will the answer? Like which one will show pure rotational spectra? N2, H2S, CO2 and methane. Just see, N2 is a homonuclear and we discussed for homonuclear there will be no dipole moment, so it will be not active at all. H2S, it has a dipole moment, so H2S will be active. CO2, it's a linear molecule, here dipole moment will be 0 as it will cancel out. Methane, here also dipole moment will not be there. So the answer is H2S. So only in H2S it will show pure rotation spectrum. This H2S. What happen if a molecule like will not show a dipole moment, a permanent dipole moment? Basically, if a molecule will not have a permanent dipole moment, then it will not generate the oscillating electric field upon rotation, and therefore it will cannot be react with the radiation, or it cannot be interact with the radiation. That's why only those molecules which have a permanent dipole moment will be active. So the answer will be H2S. Now, next question. The third lowest microwave absorption frequency for 13C 16O is 330567 MHz. The second lowest absorption frequency for 12C 16O should be at. So, what will be the answer for this? Just take 2 minutes time to solve it and tell me the answer. You have to calculate the second lowest absorption frequency. You know the third lowest microwave absorption frequency is 6B. Like for the first is 2B, for the second lowest absorption frequency it's 4B. So that you have to calculate. So for the third lowest microwave absorption frequency 6B, it's given it is 330567 megahertz. You know a relation that B is inversely proportional to the reduced mass. So like for carbon 12, here divided by B 13 carbon 16O, as it is inverse, so it will be mu of carbon 13 16O. Similarly, mu of 12 carbon and 16O. So you basically you know the B for the 13C. So for the 12C you will calculate 12 carbon 16O. It just multiply this here, so it will be V of 13 carbon 16 oxygen divided by mu of 12 carbon 16O multiplied by V of 13 carbon 16O. So now can you calculate it? This B value will come from here. You know the 6B for 13 carbon is this. So here B will be 330567 divided by 6. Substitute the value here.
First option.
First option. Anyone else have solved it? Let's see what will the answer. So here it's the reduced mass, na? 13 into 16 divided by 13 plus 16 divided by 12 into 16 plus, so divided by 12 plus 16 multiply by 330 567 divided by 6. So after solving, it will be 230510 megahertz. Is it clear up to here? Like, is it clear? How do we like? No, B is inversely proportional to reduced mass. So for B, for the carbon 12th isotope divided by 13th will be mu is equals to, as it is inverse, so it will be 13C then divided by 12C. So from here you know that from third lowest for the 13C was given. From here you calculate the value of B. Now substitute the value of B and reduce mass, then you will get the value here. Is it clear? Actually, the after calculation, whatever the value will come from here, it will be for the B of 12C. Now you know for the second lowest absorption frequency, it's 4B. So just multiply the value by 4. So what will be the value here? Like after solving it, It will be 5, 7, 6 to 7.58. So now you know for the second lowest it's 4b. So just multiply this by 4. So after that you will get this value 230510. Is it clear? Is it clear?
Yes.
Okay. So moving to the next question. Which of the following molecule will show pure rotational spectrum? Methane, water, benzene, and Cl2. So what's the condition to know whether molecule will show it or not? It should have a permanent dipole moment. That is, it should not have a zero dipole. So out of these, which will have a permanent dipole moment?
H2O.
H2, correct. Now the next question is the rotational spectra are observed in the near IR region, visible, far IR or UV. Where do you observe the rotational spectra? You know the electromagnetic series? Like it's
IR, visit IR.
IR. Which IR? Near IR or
near
far?
near near IR.
XUV IMR. It will be far IR because first near IR comes, then mid, and then it's far IR. Far IR will be observed. Like in far IR region, rotation spectra will be observed. In the hydrogen molecule, when hydrogen is replaced by deuterium, what will happen to the rotational constant B? Will it increase or become zero, or it will decrease or will remain the same? We are just replacing
Decrease.
it will uh,
Decrease, ma'am.
decrease. Why?
Because reduced mass is in the denominator.
Okay, yeah. We know that B is inversely proportional to reduced mass. And you know, if hydrogen is replaced by deuterium, then the mass is increased. So if mass is increased, then BB, the rotation constant, will automatically decrease. Now the next question. The OH minus radical has a moment of inertia of 401.48. Oh, actually, there's a mistake in this question. Calculate its internuclear distance. s- we can move to next question. Spectroscopic transitions leading to rotation of molecules will appear at which region of the electromagnetic spectrum? Ultraviolet, radio frequency, infrared, or microwave?
We are unable to see the question actually.
Why is the screen not visible? It is like, is it like the screen is visible or not?
Yes, yes, it's fine. Yeah.
It's fine.
Yes, yes, we can.
The spectroscopic transitions leading to rotation of molecules will appear at which region of the electromagnetic spectrum? UV, radio frequency, IR, or microwave? So it will be microwave. In the previous question, there was some mistake. It's the moment of inertia is 1.48. It should be 1.48 into 10 raised to the 40 minus 40. So now calculate the internuclear distance and also calculate for j equals to 5 its angular momentum and angular velocity, and determine the energy absorbed in the j equals to 6 to j equals to 5 transition. So moment of inertia is given, you have to calculate the internuclear distance. So how you will calculate it? You know this formula, I is equals to mu r square. This r you have to calculate it as it is internuclear distance. Mu is reduced mass, I you know. So firstly, determine the value of mu. So it will be mass of O and H, like mass of O multiply mass of H, then addition of both the masses. So it will be 1 into 16 divided by 1 plus 16. Also we can multiply, like we can multiply by 1 by Avogadro number. So after solving it, the reduced mass will be 1 point. It will be 1.56 into 10 raised to the minus 24 gram. So now substitute the value here and just tell me what will be the value of the internuclear distance. What will be the value? You just have to divide these two values. What will the value of internuclear distance?
-9.74 to 10 raised to -9.
Okay, or you may write it as 0.97
Next.
Armstrong. So now you know the value of R. Now you have to calculate the angular momentum. And you know angular momentum is L, and there's one formula to calculate it. It's under root J, J plus 1 H into 2 pi, H upon 2 pi. So now substitute the value of J. It's given in the question, it's 5. H, you know, it will be under root of 5. Uh, just a second. It will be 5, 5 plus 1 into 6.626 into minus 34 divided by 2 into 3.14. So after solving, what will be the value of angular momentum? So it will be under this term, maybe under root 30. Just multiply these two. What will be the value? Here also just you can convert this value into erg. So you just by converting it will be minus 27 when you will convert into erg per second. Erg second, sorry. So now what will be the value of angular momentum? It will be 5.77 into 10 minus 27. So it will be, I will write here 5 point value of L will be 5.77 into 10 minus 27. Ten minus 27. So now you have to calculate the angular velocity. Angular velocity is given by W omega equals to L upon I. This is the formula. L is I omega. Now substitute the value of L. It's 5.77 into 10 minus 27 divided by I. I will be 1.48 into 10 minus 40. So what will the value of angular velocity? So it will be 3.90 into 10 raised to the 13. Now just you have to calculate, like the remaining part is determine the energy absorbed in J equals to 6 to J equals to the 5 transition. So how you will determine the energy? You know, for energy E is equals to h mu or hc by lambda. So for energy you should know the formula of wave, like you should know the value of the wavelength. So firstly you will, or hc by wave number. 1 by wavelength is wave number, as wavelength is not given, but you can calculate the value of this. You know this formula mu equals to, like first I will erase this. So mu is equals to 2b j plus 1. So you have to calculate the energy absorbed in J equals to 6 to J equals to 5 transition. So here J is the for the lower state. So it will be 2B 5 plus 1. And for B, you know the formula, that it is 12B. And for B, the formula is H upon 8 I square I C. I is the moment of inertia. Now you know all the values. So from here you can calculate easily the value of V. It will be 6.62 into 10 minus 27 divided by 8 into 3.14 whole square into pi is 1.48 into 10 raised to minus 40 into C. C is 10 raised to power 10 centimeter per second. So what will the value of this wave number? it will be 227 centimeter inverse. Sorry, not wave number, it's B. So you know mu is 12B. Just multiply by 12. It's 227 centimeter inverse. So it will be, what is the value after solving? Oh, maybe after solving whatever will be the value, after solving the value of B and putting it here, then the value will be 227.
7
Uh, please repeat. Not here, it will be directly like after substituting that
2
to 7 centimeter inverse. Now you know energy is equals to Hc mu, but now it's wave number mu bar, then 6.6. Then it will be 6.626 into 10 minus 27 into 3 into 10 raised to a 10 into value wave number is 227. Then after solving, the value of energy will be 4.5 into 10 raised to power 14. Like this will the value. Is it clear up to here? Like up to this, is it clear? Basically, in this question, you have to just remember some of the formulas that we have to use to calculate angular momentum, angular velocity, moment of inertia, like I is equals to mu. Please repeat. What I,
Remember calculating this rotation constant B. Can you
yeah,
hear me?
yeah.
Now, while calculating the rotation constant B, that in that denominator part there is like moment of inertia term I, right? So for that I, here it is given in grams centimeter square. So should we convert it into kilogram or something like that for getting 227 centimeter inverse answer? Because I find the answer is not that right which I did.
Yeah, you should convert it.
Okay, ma'am.
It depends. Like if you are calculating the energy in Earth, then 10 minus 40 is right. But it depends. If you're calculating in this like in Earth per molecules, then it will be 10 minus 40 only.
Okay, ma'am.
Yeah. Like both the answers will be right. Just make sure your units are correct. Like if you will just write here in kg, then make sure you write the unit of energy properly. Now the next question. The microwave spectrum of a rigid diatomic molecule shows first three lines at 2.65682 centimeter inverse, 5.31364 centimeter inverse, and 7.97046 centimeter inverse. What is the rotational constant of this molecule? So how you will solve it?
We are unable to see the screen actually.
Hmm? Is anyone saying anything?
Yes, yes, it's now okay. It's okay now.
So how you will calculate the rotational constant in this question? You have been provided with the microwave spectrum of first three lines. You know the difference in the rotational lines is shown by 2b.
Is it 2B?
Huh.
From 2B, we can get J, right? And from there, we can get.
By subtracting these two values, like 2b is the spacing now. So just subtract these two values, 5.31364 minus 2.65682. So the value of p after solving will be 1.32841 centimeter inverse. You know the difference in the rotation lines is 2b, and it will be equal to the subtraction of these two terms, or like you can also write like 7.97 minus 5.31. The answer will be the same in both cases. So moving to next question, which of the following molecules will give pure rotational spectra? O2 methane, H2HCl, H2CO, and HClCO. So what will the right answer? Now we have discussed a few questions related to this, like which will show or not. So what will the answer? Which of the following molecules will give pure rotational spectra?
Option 4.
Option 4. Okay. Anyone else? Anyone else? Is it right? It will be HCl and CO because in both, like in, actually I can't hear you. Actually in both, they be a permanent dipole moment. So these two will show a pure rotational spectra. Moving to next question. Calculate the moment of inertia I of a molecule HCl. The masses are given and the equilibrium bond length is also given. So just calculate the moment of inertia. So how you will calculate it? Is anyone trying to say something? Venu? Actually, I'm not. Your voice is breaking.
నిద్రపోయింది.
So how you will calculate the moment of inertia? You know the formula I equals to mu r square. Everything is given. Just you have to substitute the values. So for HCl, its mass is 1.673 into 10 raised to the 27 multiply by 5.807 into 10 raised to the 26 divide by 1.673 into 10 raised to the 27 plus 5.807 into 10 raised to the 26, and what's r? It's 1.275 into 10 minus 10 as it is in Armstrong. So after solving it, the value will be 2.644 into 10 raised to power 47. Option A. Now the next question is calculate the position in centimeter of the J equal to 6 line in the pure rotational spectra of the hydrogen deuteride molecule HT. The masses are given and the equilibrium bond length is also given. This you have to calculate the position. So I'm giving you just 2 minutes time, just solve it. Masses are given, bond length is given. Just you have to calculate the position. Which formula you will apply? You know it will be J plus 1. This you have to calculate now. And you know the value of J. But firstly we will calculate the value of B. And what's B? It's H divided by 8 pi square IC. And for this equation you should know the value of I. I is mu r square. Just first solve the value of mu as these two masses are given. Then by equilibrium bond length, then you'll get the value of I, and then substitute this value I in this equation as you know H and C. So then after when you will get the value of B, then substitute the value of B in this equation, and finally you can determine the position. So I'm just giving you 2 minutes time. Just solve it. Just tell me what will be the value of B. It's simple. I equals to mu r square. You have to calculate the reduced mass. You know m1 m2 upon m1 plus m2. Mass is already given, and the bond length is also given. The r is given. So now you got the value of moment of inertia. Then just substitute the value in this. Like h you know, c you know, now I you also know. So just tell me what will the value of b. Arpita, Arun, Deepak. What will the value of b? Keshav, Princey, Thakur, Vaishnavi, and Venu. Is anyone solving it? Like you just have to substitute the value. First calculate the value of I, then put in that equation h upon 8 pi square IC. Then you will get to know the value of B. So what will be the value of B? So the value of B will be 44.73 centimeter inverse. That's B. So position you know it will be by 2 pi, sorry 2B, J plus 1, J is 6, so it will be 2 into 44.73, 6 plus 1. So after solving it, the answer will be 626.27 centimeter inverse. Is it clear up to now? Is it clear? Am I audible?
Yes.
Okay. So now the next question is the relationship that is true in case of prolate symmetrical rotor is, what will be the answer for a prolate symmetric rotor? It will be IB is greater than IA and IB and IC are equal. Now the next question, molecules containing the vibrations without the center of symmetry are IR active and Raman inactive, IR active and IR inactive, both Raman and IR inactive, both IR and Raman active. So what will be the answer? Like without the center of symmetry, will they be either active or inactive? So as both will be IR active as it will be IR active and Raman active. Then only there will be a dipole moment. So it will be active. Now the next question. Identify which of the following pairs of molecules exhibit both a pure rotational spectrum and a rotational Raman spectrum. Oxygen and water, CO2 and N2O, CO and methane, NO and DCCH. So what will the answer? How do you
Oxygen
know?
in water.
Pardon? So what will be the condition for a pure rotational spectrum? We already discussed. When you will say like a molecule will exhibit a pure
Oxygen in water, right?
oxygen and water, okay. Anyone else? Uh,
And screen is not showing.
Skin is not visible. Just a second. Like it's already shared actually. I don't know why.
It's in previous slide, ma'am.
Now is it visible?
Yeah, 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 ma'am.
Okay. Just tell me the condition. Like what's the condition that the molecule exhibit pure rotational spectrum? We have discussed. Like what's the condition for pure rotational spectrum?
Paramagnetic.
Not paramagnetic. It should have
Change in
a
dipole moment.
it should have a
Dipole moment zero actually.
it should have a permanent dipole moment. And for rotational Raman spectrum, what is the condition? For rotational Raman spectrum.
Vibrations and
For this, the condition is that the polarizability must be anisotropic. That is, it should not be same in the all direction. And like oxygen, it is a homonuclear, so it is not. So it will not exhibit a pure rotational spectrum. CO is a heteronuclear, so it will have a pure rotational spectrum. NO will have, but CO2 will also not have because dipole moment is zero. Similarly, N2 will not have. So out of these two options are will not be there. Now these two are remaining: CO and CH4, NO and DCCH. And you know that CH4 is a non-planar molecule. Methane. It has tetrahedral shape. It is non-molecule. It will have a weak rotational spectrum. Weak rotational spectrum. So the answer will be NO and DCCH. How many normal modes of vibration are there in C60? What will the answer? Like you have to calculate the normal modes for C60, the carbon 60. It's simple. We have discussed multiple times.
3n minus 5.
It will be 3 n minus 5 or 6. Like C60 is a linear, non-linear molecule. Is it linear? Is it linear?
Non-linear. 3n minus 6.
Non-linear. Yeah, it will be 3 n minus 6. So n here is 60.
174. Answer.
174. Correct. So now the next question is, which of the following molecules will display will not display an infrared spectrum? CO2, N2, benzene, HCCH. Now this is very easy question. Now everyone can answer this. Just remember which will not display. Not display. So what's the answer? CO2, N2, benzene, HCCH.
N2.
N2. Okay.
N2.
Now the next question. Which of the following compounds is consistent with the IR spectrum, showing a broad absorption band at 3000 cm inverse with some sharper bands appearing on its shoulder at about 2030 cm inverse, a strong absorption at about 1700 inverse centimeter inverse, and a sharp band at 1500, a series of sharp bands between 650 and 800. So what will be these? Like there's a broad band at 3000, some sharper bands like shoulder band at 2900. Just tell me like 1700. But do you observe at 1700?
C was stretch.
Like carbonyl group. So 1700 is a characteristic peak for the carbon. Like all carbonyl containing will nearby come at around 1700. And here at 3000, it's a broad peak. We already discussed. Like it will be OH. Now there are shoulder peaks at 2930. So it will be for CA stretching, and for 1500 it will be for the CC stretching. Now what about 650 and 800? What are these peaks? Like what are the bands? Like it will correspond to aromatic CH bending. Just remember when there is carbonyl, then there will be near about 1700 for oxy, like for hydroxy group. It will be a broad peak at about 3000, 3300. And like for CH bending, that is for aromatic CH bending, it will be between 650 and 800. So now what will be the answer? Now you know that
Option B.
Answer B.
B. Yeah, it will be. Now moving to the next question. For which of the following molecules would you expect the infinite active fundamentals to be Raman active and vice versa? NO2, fluorobenzene, benzene, fluoroethene. Like for IR active to be IR to be Raman inactive.
NO2.
NO2 wrong. Answer will be benzene. Why? Why it will benzene? Why it will benzene? Because of the inversion center. Now let's revise what we have discussed. Just you have to remember the values of near IR, middle IR, far IR, and then like for if the molecule is linear, then the number of moles will be calculated by 3 and minus 5. If it will be non-linear, then it will be calculated by 3 and minus 6. And what's the condition for a molecule to be IR active? That it should there should be a change in dipole moment. Then only molecule will be IR active. Like for symmetric stretching, it is IR inactive as there is no change in dipole. Now you know Hooke's law, it's F equals to minus kx. Then we discussed about a relation of vibrational frequency with the bond strength, that mu is equals to 1 upon 2 pi under root k by mu, where k is the force constant, or it tells about the bond strength, and mu is the reduced mass, and it will equal to m1 m2 upon m1 plus m2. Then we just discussed about some peaks like at 3300 a strong peak will be of for the hydroxy group, and a band at 1050 is a characteristic of primary alcohols. Now if you have to differentiate a primary amine and secondary amine, by then the both the NS stretching will be different. Like for acetaldehyde, we discussed the carbonyl stretching will be approx 1730, and in ethanol, the OS stretching is near about 3600. Then we discussed the numerical about how to calculate the wavelength, frequency, force constant. Now moving to rotational spectroscopy. So for the selection rule is that delta J should be plus minus 1. Here also if a molecule has to absorb microwave radiation, then it should have a permanent dipole moment. Like all the homonuclear diatomic molecules are inactive as there is no as the dipole moment is 0, while the heteronuclear diatomic molecules are microwave active as there is dipole moment, like it's HCl, CO, NO, HBr. In all these there will be dipole moment. That's why they are microwave active. Like similarly, the triatomic and polyatomic molecules like water, N2O, OCS, ammonia, chloroform, this also all have a permanent dipole moment. That's why they are microwave active. Then we discuss this formula. Like you should know the first lowest absorption frequency is 2B. Then for second it's 4B, and for third it will be 6B, and so on. Basically, what will the condition to know which molecule will show rotation spectra, pure rotation spectra not, is that if it help if it will have a dipole moment, a permanent dipole moment, then only it will show a pure rotation spectra. Then we discussed that the rotational constant is inversely proportional to reduced mass. So if reduced mass is increased, then the rotational constant will decrease, and vice versa. As in the question, the hydrogen was replaced by deuterium, so mass was increased, therefore the rotational constant value decreases. Then we discussed about how to calculate moment of inertia. The formula is I is equals to mu r square. Then angular momentum is equals to I omega, where omega is the angular velocity. Then we discussed how to calculate the rotation constant values. If the values of the first lines are given, we know that the difference in the energy level is denoted by 2b. So just you have to subtract these two lines or third and second line. Then you calculate the value of b, that is rotational constant. Then the relation between the prolate symmetric rotor is denoted by this. For a molecule that contains the vibration without center of symmetry are both IR and Raman active. Then we again discuss like fullerene. C60 is fullerene basically. It's a non-linear molecule. So the number of moles will be calculated by 3 and minus 6 as Na16 in this case. So it will be 174. And for linear, we know it by 3 and minus 5. Then we discussed about IR spectra, like the peaks are sharp peaks between 650 and 800. It corresponds to the aromatic CH banding. 3000 it corresponds to a hydroxy, and 1700 it corresponds to a carbonyl peak. That's all today. Is there any doubts?
Maybe in the week one assignment there was a question, right? Uh, 10th question, like we have same kinetic energy and which one will have greater wavelength. Actually, the answer was given as photon has greater wavelength, but when we found out it was like moment of photon is actually greater than electron, then obviously wavelength of electron should be greater than photon, right? So there's a confusion on that part.
Okay, maybe the answer was wrong there. You're right.
There it is. So uh, they reduce the marks. That's why I wanted to
Okay.
ask you that. It's right, like wavelength of electron should be greater than photon, right?
This is in this assignment.
Week one, question number 10.
Okay, I will just check and maybe in the next class I will tell you. Actually, I don't know.
Okay.
Like what? Like, can you just maybe in the chat box? Maybe you can write the question, or you may we write the question in the discussion forum,
Okay, ma'am.
or if possible, you can write now also, like in the chat box. But what you are
Should
saying,
I write the full question or should I mention the
it's
question
up to
number and
you.
the week?
It's up to you. But whatever you are saying
Okay.
is right. The answer should be that only.
Okay.
Anyone else have some doubts? If you feel like my speed is more, or like I might reduce it, like you can give suggestions as well. Like is everything clear? Like what I taught today or in the previous sessions? Okay,
Ma'am,
Vaishnavi.
there is one more doubt also. So, we are from the physics background. So, this is a general doubt, okay? So, you said like C60 is of non-linear structure. So,
Non-linear.
we don't know how is it. Can you just
Okay, you are from
tell?
physics background.
Yes.
Okay. Uh, Actually, like basically CO2. CO2 is a linear
Hmm.
molecule.
Okay.
Like C60 is like it's like a bow-like structure. It's of Buckminster fullerene. It's a bow-like structure. It's not linear.
Okay. Okay.
Yeah.
Okay. Okay.
Okay, thank you.